This conference is brought to you by CallStack, your React and React Native development experts.
Hello, I'm Jay. It's super cool to be up here. React Native EU was my first ever conference in 2018, and so it's an honor to finally be standing up here. I'm going to talk to you today about Legend List, which is now the fastest list for both React Native and React. First, I have a quick question for you. Raise your hand if you've ever had performance problems with long lists in either React or React Native. That is literally everyone. All right. So React Native is amazing in almost every way, but the seemingly simple thing, just having items in a list, was surprisingly slow. So for some reason, I decided to try to solve this, and I thought it would be easy. It was not easy, but here we are. It's going pretty well, and I have two announcements today. Legend List version 2 is now stable and released on NPM today. And also, web support is now released in beta. So it's actually worked in React Native Web for a little while, okay, but now it works in React DOM as well. So this has been months of work to completely rewrite the core without breaking anything and to try to make it faster. So today I want to tell you about how the changes in version 2 work, some new things I've learned about optimization, and some differences in optimizing for web. So first I'm going to show you the advanced tools I use for performance debugging. It's console log. So seriously, I just use console logs to see what's actually happening, in what order, and how long it takes. And my friend Herbad gave me a really slow phone when I started this project, because optimizing is mostly about how it looks on slow devices. I run a script to scroll at a consistent speed using this very slow phone. I cannot emphasize enough how slow this phone is. It's terrible. So I just watch how it behaves. I watch the FPS monitor, which is a big help. But it's also important to just feel it with a low frame rate because phones are going to be slow. So my optimization philosophy is just 3 words: render less, less often. The normal way in React to update items in Vue would be that you would create a new array of items, re-render the containers array, and then let React do all the diffing and reconciling all the way down. But list scrolling is a big bottleneck, so to maximally optimize this, we need to get a little nuts and do it differently. So Legend List just skips all of that. It never re-renders that containers array, so while you're scrolling down and a new item comes on screen, it recycles an old container and signals to that container to re-render itself at the new position with the new item. So it results in the same thing on screen, but it skips all the work in the middle. It just re-renders the one container that changed. But that's how Legend List already worked. So let's get to the one reason why version 2 is so much better. It's maintain visible content position. It's finally correct. So this seems like it's just one feature, but it's actually the key to everything. And it's also surprisingly hard to say, so I'm going to call it MVCP. So MVCP makes it so that when items change above the viewport, the items you're looking at in the viewport don't move. So this is really important when the items are at dynamic sizes because first we render an item at an estimated size and then adjust it after it renders. So if we put things above the screen and we don't actually know the size, when it actually updates with the size, it could shift all over the place. So without this, everything would be jumping around while you're scrolling or scrolling to index because positions keep changing on you. So the way we did it in version 1 sometimes had a delay of a frame, sometimes it affected momentum scrolling, sometimes it made the scroll view just scroll itself. But with a few small changes, I finally fixed that for good, about 5 times. People kept finding new ways to break it. I was on this emotional roller coaster where at night I finally fixed it, and then I woke up in the morning and it was still broken. So I went back to basics and started over, and I found a better algorithm for it, which is instant and it doesn't affect scroll momentum at all. So you can see in this video, I'm scrolling up infinitely, continually adding items of random sizes, and it's perfectly smooth. MVCP working correctly also let me just remove hundreds of lines of hacks and workarounds that were previously needed to make it work correctly. And it just made everything easier. And most importantly, it enabled accurate scroll to index. The problem with dynamically sized items is when you're trying to scroll to an index, we don't actually know where it is. We don't know the sizes of the items between them. So we have to just guess. And so we guess based on the estimates of what the sizes should be and adjust the positions while scrolling. In version 1, it mostly worked okay, but it could sometimes miss the target. So we had all these really silly workarounds where it would sometimes just scroll multiple times to try to get it right. But with the new MVCP, when you scroll to an estimated position, the target element moves itself into the estimated position, so the estimate becomes the correct position. So it's perfectly accurate every time. It also made it easy to add sticky indices, which was a surprisingly highly requested feature that I had never used myself. But it was a blocker for a lot of apps to switch over to it. We'd attempted it unsuccessfully a few times before. We had these big PRs and long discussions about it. But after V2, I did it in an hour on a train ride. It was very easy. It also allowed an optimization that I had tried many times. So positions need to update really often. In the initial mount, you usually have to update the position, and then anytime any size changes, you have to update it. So it's a shame to have to re-render the whole component every time just a style changes. So the part that sets position style is now just its own component that only handles that style. And on old architecture, it actually sets an animated position, so this never actually re-renders at all. But on new architecture, it's a different optimization, because in the new architecture, layout measuring is synchronous. And a cool feature of React is that if you set state in a useLayout effect, it just runs again before it actually renders the screen. So we can update an element, measure the new size, update positions in the list, calculate what's in view, re-render the new positions, all in one frame before the user sees it. So you'd never see any gaps or blanks or anything while you're resizing stuff. So although we have to re-render twice, it's actually not that bad because it all happens in one frame. So that brings me to the next big thing that the new MVCP opened up. It was much easier to build a web version. So going into building the web version, I thought the main difference would be that web needs items to be in order. But React Native, the order doesn't really matter because you can't select anything. So legend list container recycling just doesn't care about order. So as you're scrolling up and down, it just puts stuff in random places. But on web, you need to be able to highlight across the page. And if the items are in a random order, the highlight looks insane. So that's not going to work. So I might have to completely change the algorithm for web to maintain the order. But first, I wanted to look at how all the other libraries do it. So starting with one called Virtuoso, it renders all the items in view with a normal block layout. It sets a padding top on the scroller to take the place of the items above the viewport. And so you can see while I'm scrolling in the dev tools, the item I've highlighted is just moving up and down the DOM as things get added and removed. But one of the problems, because everything's normally positioned, anytime something changes, it does a big layout in the whole list. And because you're setting padding top on the container, you're also doing a layout of the whole list for that too. So then let's look at an example I saw in the TanStack virtual docs. It works pretty similarly. It renders items in view normally, but it does the top offset by setting a transform. And so that seems like a good optimization, right? Transform is better than padding, but it's actually terrible. Because in this case, transforming actually has a huge negative effect, because in a browser, when you set a transform on an element, it moves it out into a separate layer on the GPU. And so the GPU has a maximum texture size of about 16K. And so if you have a scroller that's like 100,000 pixels tall, the GPU has to split that into 16K chunks, transform all of them, stitch them back together, and then composite that onto the page. So it avoids a layout, but it's then doing all this work on the GPU, so it hits you in graphics memory and compositing time, which is not great. So then let's look at Virtua. Virtua works very differently. It absolutely positions each item. That takes it out of the layout flow so that resizing items does not trigger a layout of the whole page. or of the whole scroller. And because it's absolutely positioning every item, we don't have to have that top offset anymore. So this is great. It avoids a lot of layouts. But the thing they all have in common is that when one item comes into view, it re-renders the whole list. And that does a bunch of work in React. Some DOM elements get removed, some get created. So I wondered how it would work to do the legendless algorithm on this. So I just ported over the algorithm from the React Native version. So it absolutely positions the items the same as it does in React Native. And when a new item comes into view, it just signals a single container to re-render itself. And this just does a lot less work. It skips all the work in React of diffing and reconciling the list, all that stuff. It updates fewer DOM elements. But there's a problem. Now we have items out of order. And so I asked Claude how to do this. It gave me some ideas. It suggested CSS has this order property on Flexbox. So this can effectively display elements in a different order than they are on the DOM. So that solves the problem, right? No, it does not. It doesn't work at all. It's only visual. It doesn't affect selection or accessibility. Not helpful. So then I asked Claude again, and it said web workers are good for performance. But what does that have to do with this? That was useless, so I had to figure something else out. So it turns out we can just move DOM elements around. So normally in React, if you add or remove elements outside of React, it can crash the app. It does terrible things. Because when React re-renders, it tries to update DOM elements that are gone, and so it's terrible. But as I showed you before, our containers component never re-renders, and only the elements inside do. So we can just move them around with no problem, and React can still update everything just fine. So Claude did end up helping me with this. It made this optimal reordering algorithm, which does the smallest number of DOM mutations to put the DOM in the same order as it should be. But also, being out of order won't be a huge problem for most users while you're scrolling. So in this video, I'm showing you there's a debounce of about a second. After I finish scrolling, it just moves everything. But since everything is absolutely positioned already, that doesn't actually affect what you see. But it should probably be faster in real life. We should probably have a prop to control it. So then I did a comparison of all the list libraries. I added a big slowdown on them to see what it looks like with heavy components. So in this test, Virtuoso and TanStack Virtual had a big problem. Virtua does pretty well though, but the legendless version is already faster. But the web support is so new, it's mostly still just the logic for mobile. So I think there's still a lot more room to optimize this, which I'm excited about. So why is this faster than the other libraries? Mainly it's just doing smaller renders. Only the one item that changed is being re-rendered instead of the whole list. So it's doing less work in React, it's doing less work in the browser. And we have recycling, which we're used to on mobile, but has never really been a thing on web. So rather than destroying and recreating elements when they come into view, we can just reuse them. Because if you're only changing an image source or some text, we can just update that tiny little thing rather than destroying and recreating a whole component. So the last big challenge on web was how to do MVCP. In React Native, it uses a feature built into scroll view. So for web, I had to implement it myself. But that was actually pretty easy. On web, we can just use scroll by to adjust the scroll. That doesn't affect momentum scrolling at all. And so that was a perfect solution, except on mobile Safari, it does not work. So I still need to figure out how to solve that. But from what I can tell, none of the other libraries can do infinite scrolling up or scrolling to index very well. So this video is showing you just starting at an initial scroll index, scrolling up. It works perfectly. There's no jank. There's no problem. It works just as well as it does on mobile. So then the next challenge is an architecture one. How do I make one library with the same API on both web and mobile? So Legend List already splits behavior in a bunch of places between old and new architecture. And the key difference is on new architecture, we can measure layout synchronously, and then we can update positions with use layout effect. And on web, we have get bounding client rect, which is also synchronous. So the web version can take the new architecture path throughout the whole thing. The general logic can be mostly the same as it is for new architecture. And then on web, there's two different kinds of event handlers. There's active and passive. So active handlers are synchronous and block everything until they've finished, whereas passive handlers are asynchronous, and they don't block. So in React Native, the onScroll event is always passive because it's the safest and highest performance version. But there's a trade-off. With a passive listener, if rendering is slow, you see blank spaces because it hasn't caught up. But then with an active listener, if rendering is slow, it'll just chug the scroll. So since Legend List is already built for passive listeners, I've just started it that way. But it's possible the active version could be better. I still need to experiment with it, so we'll see how that goes. So with all that, Legend List version 2 is even faster in React Native than V1 was, and it's now the fastest on web as well. And it's also very powerful with all these new features working reliably. So what's next? Version 2 is released today. Give that a try. It's much better than version 1 was. And web support is also in beta today. It barely works, just a warning, but you can test it against other libraries and see how it's going. So I'll be improving on that over the few weeks. So I'm really excited to see what you all can build with this, but I need your help. Please report any problems that you see and send me PRs. A lot of people will just patch the package in their own library. That does not help. Please tell me what's wrong and we'll fix it. Everybody uses lists in a very different way, so people often find bugs I never even thought to test. And if you want your apps to be really fast, I also make Legend State, which is the fastest state library in React. And it's also a full local first sync engine, if you need that. And if you see me around, let's chat about performance, or talk to me on the various internets, and let me know if I can help with anything. Thank you.